Hello student, myself Nimesh Pravakar. Welcome to Process Control lecture series. In my previous lecture, we discussed about two-position control mode. That means it is also known as on-off control mode. So in that lecture, we discussed how it works. Now in this lecture, we discuss this mode, that means multi-position control mode. So, as name indicates, you can understand multi-position control mode. That means in an on-off control mode, only two positions is possible. That means by using that controller, we can on or off. Here, multi-position. That means we vary the controller output at multiple positions. That means here we can control we can give the output more precise way. So now we start how it works. So first of all, one question come in our mind: what is multi-position control mode? So the answer is, it is the logical extension of two-position control mode to provide several intermediate settings of the controller output. So the multi-position control mode is nothing but the logical extension of two-position control mode. That means in a two-position control mode, only two position is given. That means one on and second is the off. Here there is a multiple position available. That means in between the on and off we have multiple position. That means it is called an intermediate position. This is possible in this multi-position controller. This continuous control mode is used in an attempt to reduce the cycling behavior and overshoot and undershoot inherent in the two-position mode. We know that there is a disturbance created due to the undershoot and overshoot problem. So this is a really very serious threat in the controlling action. So here we use multi-position control mode. So we can reduce the action of undershoot and overshoot. This control mode can be prepared whenever the performance of two-position control mode is not satisfactory. That means in some time we require multiple mode. That means we can understand by help of one example. That means here we have to control the liquid tank system. So in the two-position mode, we have only two options. That means what? We have to open full valve or we have to close full valve. But at the same time we require to increase the flow or decrease the flow. So at that time we require multi-position control mode. So this can be possible by help of the multi-position control. The general form of multi-position mode is represented by P is equals to Pi when EP is greater than EI. Here the I indicate 1, 2, 3 up to N. That means when the controller output is P is equals to Pi when EP is greater than EI. As the error exceeds certain set limits plus or minus EI, the controller output is adjusted to present value Pi. So this is the multi-position control mode. Now we start with the 3-position control mode. This is the example of multi-position control mode. So this is the graphical representation of 3-position control mode. One of the best example for the multi-position control mode is 3-position control mode, which can be expressed as P is equals to 100% when EP is greater than minus E1. P is equals to 50% when the EP is between minus E1 and E plus E1, and the P is equals to 0% when EP is less than minus E. You can see in the graph, that means in this figure, when the control output is 100% when EP is greater than minus E1, and 50% when the error is between minus and plus E1, and the 0 when EP is less than minus 1. As long as the error is between plus E1 and minus E1 of the set point, the control system at the some normal setting indicated by a controller output of 50%. If the error exceeds the set point plus E1 or more than the output, then the output is increased to 100%. And last one, if it is less than the set point minus E1 or more, the control output is reduced to 0. So this is the controlling action of 3-position control mode. You can understand by help of this figure. Here you can see the controller output is 50%. That means what? At that time the error is between minus E1 and E2. That means minus E1 and plus E2. If there is a E1 is greater than, that means error is increased. So the control output is increased and goes to the 100%. And if error is decreased, then output goes to the 0. So this is the behavior of the 3-position control mode. Now there are some limitations of this control mode. So which are that? So first one limitation of this control mode is the 3-position control mode usually requires a more complicated final control element because it must have more than 2 settings. That means in this control mode, complexity is increased because here we increase number of modes. So that's why complexity of this controlling mode is increased. So here, in a 2-position control mode, only two possibility is present. But here we increase the possibility of the output controlling. So that's why the complexity is increased. But we get better result. So the result is very good as compared to the 2-position control mode. Now for the better understanding, we consider this figure. So here in the figure show the relationship between the error and the controller output for a 3-position control. The finite time required for final error element to change from one position to another is shown in figure. The graph shows the overshoot and undershoot of error around the upper and lower set point. This is due to both process lag time and the control lag time. So here, first one graph indicates the error and second one graph indicates the controller out. So here you can see this is the plus E1 and minus E1. Between that portion, the controller output is 50% fixed. And then if the output is increased, now you can see in the graph, the output is increased beyond the plus E1. So at that time, the controller output is also increased. So you can see this is the controller output is increased, but at that time some delay is occurred. We know the control lag and process lag and undershoot and overshoot procedure. So due to that, there is some delay is created to require some time to increase the output. So there is some delay. So if the error goes beyond the plus E1, so at that time the output is increased from 50% to it goes to the 100%. And now it stays there. That means we can see is between the portion at that time the output is fixed at the 100%. Now when the error is decreased from plus E1, then at that time the output is also decreased. That means 100% to goes into the 50% value. So between the plus E1 and minus E1, at that time controller output is fixed. That means 50%. And when again you can see when the controller output is decreased, that means the error is decreased from minus E1. At that time controller output is also decreased. See in the figure, the minus E1 is indicate the lower level. Beyond that limit of the error, at that time controller output is decreased. So here we can get 50% to controller output goes to the 0%. And when it gets again, it's when it's come in the natural zone, that means plus E1 and minus E1. So at that time controller output is 50%. So this is the behavior of 3-position control mode. So this is the 3-position control mode. So in this lecture we discussed about the multi-position control mode and 3-position control mode. This is the example of multi-position control mode. So in the GTU, there are the most important question asked. Explain the multi-position control mode, or sometimes it also asks to explain the 3-position control mode in the 7 marks. And my previous lecture question is also asked, like explain the on-off control mode, and 1 to 2 marks. There is also a question asked like what is the process lag, what is control lag, and some example is also asked in the GTU. So in this lecture we discuss multi-position control mode. Thank you.